So today we're going to have, well, right now, we are going to have Cesc Guim, the CEO of OpenChip. He will share with us what are the changes happening in the world, in society, in technology, and how OpenChip is contributing in empowering this industry. So thank you, Cesc, for being here with us. Yes, thank you.
Thank you. OK, let's get started. So good afternoon, everybody. So I'm going to talk about digital sovereignty and what that it means. So I'm going to talk specifically on computing, OK? Processors, like all your cars that you have certain amount of processor that they manage the front desk that you have, giving you advice when there's a pedestrian crossing. You have your laptops, you have your desk, and everything comes with processors. For the ones that you are not familiar with how a processor is designed and the different elements that are part of it, I just want to start with some facts that give a little bit of perspective at which point of time we are and how complex the systems that we are building are. So let's get started with the size and the amount of elements that these processors have. So today, when you look, like, for example, human hair, right? So human hair has 50 to 180 microns of diameter. And you can go down to very small particles. And everything is at the micron level. Now, when you look at the technologies that are being used today to develop systems, we are going at the level of Armstrongs, which are 2 levels smaller in terms of a micron. So, like, for example, today with technologies that are being developed in big semiconductor companies, so we're talking about transistors that they are the size between 3 and 4 nanometers. And each of the CPUs that we design, they have billions, tens of billions of those transistors. So if you look like how technology has evolved over the last 5 to 10 years, so the size of the systems are becoming increasingly complex, and that implies that not all the countries have access and can develop this level of sophisticated processors and technologies. The second part is, and that's a little bit, I know that many of you probably are not technologists, and you are not part of the, it's not part of your day-to-day, but the other interesting change that is happening is processors and CPUs and technologies like that include semiconductor. Typically in the past they've been designed in a monolithic manner. So what that I mean is kind of, if you build your car, like the car is produced in one single piece. But the models that we are doing now, the car is developed by multiple different pieces that you put them together to create the car, right? And the same thing happens with the next generation of CPUs that we design. So when you look, for example, the laptop, the CPU that you have in your laptop, so the previous designs up to maybe last 2 years, when you go into the manufacturing facility that produces chips, a bunch of those chips are being generated. But now that has changed a lot over the last couple of years, and now what you have is that the manufacturing facilities develop very small chips that they are assembled together, and they deliver the CPU that you have in your laptop or in your servers and whatnot. And that's very important because now if you look from the perspective of an European ecosystem, so now it implies that many different players now can work on designing different of these chiplets or chips that I'm talking about, and others can put them together, right? So that implies that there's a potential economy for Europe in terms of the chiplet market. And I know that probably for many of you, now I'm still speaking a little bit on, let's say, extraterrestrial type of language, but now I'm going to start getting closer to something more tangible. Now, the other important aspect in terms of changes that are happening, so is energy, right? Energy, like the last few years, we've been more aware on the impact of the energy in our bills, in our day-to-day, into the carbon emission, and so on and so forth. So now, for a second, think about how many energy or carbon emission the compute that we use in our day-to-day generates, right? So when you go into, and still here, this doesn't probably resonate to you, but all of you are using ChatGPT, Facebook, and all those things in your day-to-day, right? And here, probably, if I'm telling you that all your requests of Facebook, they go into a data center, that data center use energy, and if I'm telling you, oh, by 2030, so each of these data centers may use 10 terawatts of energy. You say, okay, what does it mean? So it means that today already, what's happening is that in some of these data centers that are used for hosting your ChatGPT and whatnot, in US, they are connecting nuclear plants directly to the data centers. Because the amount of energy that is needed to feed the systems, the compute, that are running your ChatGPT, Facebook, and whatnot, requires a lot of energy. And that's a fundamental thing, like for us in Europe, that we need to, I mean, in my opinion, like Europe has, in terms of values, sustainability, citizenship, and whatnot. It's one of our cores of society, right? So I think that this model is not the one that we want. The fact number 4 is obviously AI. So AI now is everywhere. And over the last few years, like for the ones that you don't know, like the ChatGPT and all these models that you are using today to generate images, to generate text, and whatnot, have been increasing the complexity of the data centers that we design in several orders of magnitude. So if you look, and this is a very recent increase that has been happening over the last 6 to 7 years, where you go into like simple models like BERT with the ones that we're seeing now with billions of parameters. And billions of parameters, again, what translate into a very powerful systems that they run very advanced AI models. And here, like the other question is, that I want to pose here for a second is, do we really need, I mean, how we are kind of controlling like the training, or how these models are being designed and trained? Because today, if you look like from some American perspective or some of the US companies, like these big models need our data to be trained, right? So, and the question here is whether we want like other companies to access to our data for their profit. And the second question is whether we trust or not the AI models that are running our day-to-day, right? Like no, I mean, there's very few people that really like ask themselves about, okay, I'm using this model to generate an essay for my homework, but many of these models, depending on how they've been training, they bring me more closer to the right, to the left, maybe biased, and this is something that we have to consider when we think around AI. And all this kind of combination of, so I talked about fundamentally like 3 different themes here. So the first one is change on technology, more and more complex, right? And we have countries like US, China, and others that they are moving fast into these technologies that are needed to build advanced systems data centers. So that means that in Europe, we have to catch up and move from a follower to a leader role as well, because we have to have access to these technologies to develop our own technologies. The second fact is about energy. I mean, my day-to-day work is about doing technologies for, like for my daughters, right? So like when you do something, like you don't want to burn the planet with big data centers to do more and more, right? So that has to be sustainable. And the third aspect is about like what I just talked about how do we democratize AI and do the AI for citizens and not vice versa. So I think that from that side of the house, when you look at the players in technology, there's lots of players in US, lots of players in Taiwan, China, and whatnot. But the interesting part that I've seen, I mean, I've been working for an American company almost for 20 years, and I have 500 patents, all from American companies. But the interesting thing is that now there's, in my opinion, there's a change in mindset that we have to empower Europe and our countries to have our own technology. And for multiple reasons that I talked about. So technology, advanced technologies, control the power, control how we manage AI. I think that we have different principles, in my opinion, with respect to other geolocations. So what I want to talk today is giving this sociopolitical context, technology context that we have in our current world, is what we are doing in terms of our small grain of salt from OpenChip to try to tackle some of these elements and how we basically can help Europe to kind of get some sovereignty in terms of compute and AI compute, right? How we can help to provide technologies that allow do AI in a more sustainable manner, how we can do AI providing some mechanisms that we can the use of AI safest for us, and how we can basically have means that we can use this technology in our day-to-day. So I just want to give a little bit of a background of what's OpenChip, because this is a company that is fairly recent, and is a company that started almost a year ago, and it's heavily supported by the European Commission and Spanish government. And it has two main shareholders, Barcelona Supercomputing Center and GTD. And the goal of OpenChip, as I was mentioning, is to provide, develop new technologies for Europe, right? And with all this legacy that comes from GTD working in the area of aerospace and defense, doing production technology for almost 40 years, and with all the background, HPC background and scientific background from BSc, our goal is to kind of add our small grain of salt, as I just said, to develop like system technologies, and I'm going to talk a little bit more about that in a second for Europe deployments. So OpenChip is a company. We were about 10 persons 8 months ago, and now we're almost 100, and we have to be 200 in few months. We have presence here in Spain, where we have our headquarters at close by the University of Catalonia, but we have locations in Italy, Poland, Germany, and Sweden. I'm going to talk about that, but one of the challenges that digital sovereignty has is talent. To develop like very advanced technology, you need profiles that they have been working in the industry for 20, 25 years, and it's extremely difficult to get people and the quantity of people that we need to develop these technologies. And one of the interesting things that this support from European sovereignty is helping is to bring people like former colleagues of mine that they were at Google, at NVIDIA. They are coming back here and working with us to try to address the local market, right? And I think that this is something I want to emphasize. And if you look at the people that is working now in the project, so it's people that has been working in outside, and now they are coming back. So now I want to talk just briefly on the pillars, right? And trying to connect like from our very humble perspective on how we can contribute to this digital sovereignty. So when you look like technology aside, right? So doing the chips that I was talking at the beginning. So what do we want to contribute in terms of the sovereignty, right? So We're focused mostly, I would say, like in three pillars, and I'm going to provide examples just not to be myself in the world of the passwords, like concrete examples. So the first one is doing a little bit on AI for citizens, no? And again, when you look on the current trends on the ecosystem, like companies are trying to do the most complex models that are more power for solve problems, right? And the reality, and that's my personal opinion, I think that the pace in which we are developing AI and those models is not the right pace. So we need to kind of have a roadmap that we really understand how AI works and do AI for citizens. Like, for example, I don't want to have giant models if those giant models are based with my information, or I want to control that information, but that's not part of the equation. We don't even know how those models are operating, and we are kind of using them as, yeah, let's use AI to do fun stuff. But the reality is that in the day-to-day, we have autonomous cars. We're using AI for X-ray analysis, like in the healthcare domain. So we need to kind of step back for a second and see how we can look at the AI, not from the extreme power, but also like from how we control it. The second aspect is sustainability. So as I talk, it's very, like, if we go into this direction on doing more and more, use more and more power, I mean, that doesn't scale, right? So the idea is how we can provide technology that takes into account how do we use power and make it more efficient, and basically like reduce the carbon footprint in a more scalable way. And the last one is technology for scale. The other aspect that we see is that when you look at the current deployment models in the past, we used to have, or if you look at the US approach, right? So we built giant data centers, and this is not the model that works in Europe, right? So we have a lot of, like our geography is different. We have like the electric grids have a different manner, like it's completely different, right? So now if you think that you have to deploy like hundreds of data centers, thousands of different locations with compute, so how do we do it in a scale? And for example, when I talk about AI for citizens, right? So today, like one of the areas that we're looking at OpenChip, you have like in your car, so you have an AI model, no? That is using some camera sensor, and you run that model, and this model says, yes, this is a person, this is a car, it's red, or you can't, you have to stop. But what happens if now someone gets into your system and change your model? And instead of recognizing persons, it says, no, there's not a person there. How do you know that? You don't know. And the hardware doesn't check if the model is the right one or not. So that's one, for example, one of the areas that we're trying to understand. So how, from hardware perspective, we can provide some guardrails that basically prevent this type of things to happen. And if you think like, and this is not a performance thing to have big model, it's basically how I have mechanisms that I make the use of AI safe for us, or safer. Safe is almost impossible. Now, when you look sustainability, so if you look how we operate as humans, right? So humans have rhythm. And if you look, for example, in a motorway, like you will have that the motorway has some rush hour where there is a lot of activity, and you have some valleys. So, and this reflects on how these data centers, how technologies are being used. And today, like very few, I mean, there are some works that are looking on how to optimize the power consumption, understanding like some of those patterns. And this is kind of an area that from OpenChip perspective, and I'm not going to get into the technical details, but basically at the system level, meaning like these data centers, how we can understand those patterns and observing the applications to reduce the power consumption. And with the techniques that we are kind of developing, we aim to have between 20 or 30% of power savings in each of these systems using our technologies. And now the second aspect is talking about technology for a scale. Is today compute is not just like one data center. So when you look in today, like your day-to-day, so you have compute that happens in the cloud. You will have like some compute that happens into I don't know, in the telco operator, that happens in the mall where you are buying your utilities, and also like each of these elements today is compute. You have TV, you have home routers, you have cameras, all those things are compute. So now the question is, can I use something that allows me to manage energy at the global scale? And when there is, for example, like here I can use more solar energy, or makes more sense to run some applications here if I can move elastic applications from one place to another. And in this context, so what we are looking is designing the technologies locally and having something that is smart, that looks at the applications and the utilization from the different end users, and try to optimize energy at the global level. And here, for example, we are partnering with companies like Submer, that they are doing immersion cooling in advanced data centers, to see how we can redesign the current way to define those systems, to kind of, when you look at the problem in a global scale, get into this level of saving. So here I just put an example on if you have a deployment that's or a large scale deployment model that you have 50,000 of nodes, which is small, like we're talking about millions of nodes if you look at European scale. Applying some of the techniques that I just showed in the previous slide and this one, you could save per year easily like 140 million of CO2 emissions, kilograms. And you can save, and this also obviously has a monetary cost. Like all this energy that you save, it can have impact into the monetary cost. So with those numbers, like when you look into, like just to give a sense on this example, so looking at this 50,000 deployment, like deployment example that I gave, that's equivalent to hitting, well, to CO2 emissions that 16,000 houses in UK emit per year. So now if you start adding up all these elements, as you look at scale, you can think about how you can impact the society, right? So very briefly, just to tell you how the different areas that from OpenShift we are working on with respect to the three pillars that I talked about. So what OpenShift does, right? Because I just talked about AI, power, and manufacturing and advanced technologies. So when you look at what we are doing as a company, so basically, like we start understanding the applications that run in our systems, and that's very important because basically that helps us to understand the requirements that they have, the type of elements that they need, memory, how much storage do they need. We are working on the software stack, which basically is kind of for the ones that are not technical, like the Windows of your system, of your machines, so that you can run very advanced applications in the systems that we are designing. And then on the bottom, you see kind of this is kind of the CPUs and processors that we are designing in OpenShift. And just to use familiarity in terms of what we're trying to do, so like all of you guys are familiar with NVIDIA. So NVIDIA, what they do is generate GPU cards that they put in their data centers, and that's where they execute all the AI models that you consume in your day-to-day basis. So what we are trying to do is to combine the hardware technology that we do with the software to deliver a system to our partners. And what runs on top of it? So for example, you can see we are working with partners in Europe and partners in Japan, for example, to kind of optimize the applications that they do, for example, for weather forecasting, flooding simulations, and other type of scientific applications. So in this last August, for example, we were in Japan working with Tohoku University that they are doing tsunami simulations. And they have to run very complex models in 15 minutes to predict if tsunami is going to happen or not to activate the corresponding mechanisms. So our hardware intends to provide a solution, hardware solution, to, in a cost-effective manner, to run these workloads with our technology. Right? And again, our goal is there are some of the segments that we have in Europe that are very critical, like HPC, scientific workloads, defense, and whatnot, that it's important that we have our own technology. And basically, that's the area that we are working. Everything that, so just to recap a little bit, right? So I started a little bit trying to give you some of the context of where Europe is now, challenge of access into more advanced technologies, the power, AI, and whatnot. I try to give you a little bit on how we are trying to contribute that from OpenChip perspective, the three pillars, no? So AI for citizens, the sustainability and the scale. I gave you a little bit of very high level on the type of products and technologies that we are developing and an example of use cases. But the question is, what are the challenges and opportunities that we have in the context of Europe? Because now you know that there are lots of, we have AI Act, we have Chip Act, we have Data Act, and we are working heavily with the European Commission to try to help to shape the directions that we are taking and where we are investing the resources, the funds, and whatnot to kind of give the resources that are needed for developing these different areas. But the question is everything about the money? Just I can pour as much money as I want to the companies, to the data, to the R&D centers to develop technology, and the answer is no. And why is not enough? I mean, money, yes, helps, but it's not enough. The first one is the talent. I mean, talent, you believe it or not, is one of the most challenges that we have in Europe and in Catalonia and in Spain to do the work that it takes to put Europe in first position in terms of technology. Just to give you an example, like if you look like where most of the talent today is located, it's US, China, and etc. And we have talent here, but we don't have enough talent. And to give some numbers, like just to do one product, like it takes, like the ones that I was just talking about, typically it will take about 3 to 4 years, orders of tens of millions to do one of those chips. And you need orders of hundreds of hardware engineers and hundreds of software engineers. And the expertise, as I said, is people average between 10 to 20, but the 50 percentile, it's about 20 plus. So we need help, and we need help on the long run, and we're working with the universities and the different research centers to make sure that the new generations that are growing stay here and work with not only with OpenChip, with local companies to help out in this endeavor. The second challenge and opportunity is the consumption of the products. So here I'm not going to get into the detail, but basically when you develop a product to be sold and you want to make revenue and a business model, so you have what is called the push and pull model. So the push is, okay, as example, OpenChip is developing products and works with customers, so the customers get used to the technology, and maybe in 3 to 5 years they are going to be buying our products. Cool. Now you have pull, that once you have the product ready to be deployed and buy, the customers have to use it and buy it. So why I'm saying all this stuff? Because we can put as much money as we want into the companies like us, and in 3 to 6 years we will deliver products. But if the European markets and the customers, like end customers, data centers, procurements and whatnot, they are not using European technology, and not OpenChip, European technology in general, all the funds that are being put into developing our sovereignty are going to be just wasted, okay? Because if we can, it's very difficult that for these emerging companies compete with the holes of the wall, NVIDIA, AMD, Intel, on the long run, if in the mid run there is no adoption on the European technology, and it has to be at the last mile, otherwise everything is going to be a scientific project, right? So I want to emphasize, like to maybe closing a little bit on the talk, is that to achieve sovereignty, I mean, Europe has talent, has to attract more talent, but we have talent, we have resources to make things happen, but still, like, Europe has to evolve to make sure that the technology that we develop is something that stays in Europe. And I have to say that I believe, I mean, I've been working in this arena for multiple decades, and now it's a very unique situation in where we are for geopolitical circumstances, for technology circumstances, for the support of the different governmental statements. And I think that is a little bit now or never, no? So I think we have to spend time, but we have to work all together. It's not just about OpenChip, it's about all the institutions, all the companies. We have to team up, because just the problem or the challenge that we are facing is so big that that's something that has to be solved in a team manner. So that's it. I think I'm just on time, so thank you very much for your time.